about my absolute favorite aspect of Japanese sword making, and that is a process called Yake Ire. Yake Ire refers to the differential heat treatment and the fast-acting quench into water that creates the traditional characteristics of a Japanese sword, i.e. that's where the magic happens. So what's so special about Yake Ire versus any other type of heat treatment? Well, on a Japanese sword, the Yake Ire process actually achieves 3 separate activities during this process. Let me explain. Here we have a katana. I forged this about a week or two ago. It's a Shinogi Zakuri style katana. You kind of can't see it, double beveled Shinogi G and the hot line. You can't see it on the blade because it's covered in clay. You might be able to see some of it here on the Nakago. You might see the bevel. I'm not sure if it's going to show up in the camera or not. But anyway, a couple of things you may notice about this katana right now is 2 things. First of all, it's straight. Second of all, it's got a bunch of goo on it. That goo is clay. You notice the clay is 2 tones. There's a reddish brown color and a gray color. And that's a process designed for twofold. First of all, to set up differential heat treatment. In essence, what that's going to achieve is the areas of red clay closer to the blade or the hog are going to be heated at a higher temperature and cooled at a much more rapid temperature than the areas with the gray clay. This is now what's going to allow for the blade to get hardened and for the spine and the bune, the shinogi section of the blade, to remain soft. You'll also notice some licking striations coming down. In Japanese, that's referred to as ashi. And what that does is relieve stress in the steel. It also helps provide for a choji clove blossom style hamon. Now, going back to the point of what I said earlier, Yake Ire serves 3 purposes. Heat treat, differential heat treat, the hamon pattern, but it also does what creates the characteristic soaring or curvature in the blade that is standard with a traditional katana. This sword has not gone into the fire. This one had gone into the fire a couple of weeks back, and you can see it has a traditional curvature on it. Okay? So we're now going to start this process and take it through. I promise I will not bore you watching me move this sword in and out of the fire for 10 minutes straight. We'll fade to black, and then by the wonders of modern technology, we'll return where the sword is actually ready to go into the quench. A couple of things I'm going to do during this process. I'm going to be testing the blade itself to ensure I get to critical temperature. I'll be using a magnet for that, trusty magnet for that. But I'll also be using, again, the wonders of modern technology. I'll be using an infrared temperature gauge as well to ensure I can keep this within a tight tolerance of around roughly 1450 to 1500 degrees Celsius. Fortunately for me, I do not forge swords in the Sengoku Jidai period of feudal Japan, so I can leverage the wonders of modern technology to make this happen. So let's get started. Welcome back. So now we're going to begin the process of heating up the sword. I'm just lightly running it through the fire to get a little even of a heat. At some point in time, when we get close to critical temperature, I'll have the lights shut off. And we'll basically start doing temperature readings. We'll look for critical temperature with magnetism or loss of magnetism. And then we'll hit it with the infrared temperature gauge as well. While we're waiting, I'll give you a little bit of background on some of the metallurgical processes that occur during the Yake Ire phase. So the 2 types of clay that I have on this, you may have noticed that it's gray and it's red. The red clay is from the Yoshihara book, where he basically utilizes a mixture of earthen clay, charcoal, and red iron oxide powder. And the gray clay, the thicker clay, is a standard satanite applied thickly across the Shinogi G line and the bune. Gotta start keeping an eye on this now, so I may Critical here during this process that you do not overheat the tip of the blade. The tip of the blade is one of the most critical pieces. And I think at this stage I'm going to have my assistant shut the light off so we can start to gauge how even the blade is heating up. So we're going to let it heat. I have my trusty magnet ready. Move through the process of cycling the blade through. Right there yet. And here we go. Now I'm going to finish it in oil. We have a curvature. Can you see the curvature there? And we'll test it for how well we heat treated it short. That is the Yake Ire process. Thank you for watching.